Okay, so for this part of the session, I kind of wanted to talk to you a bit about some of the issues that you might find when you're scaling Shiny. It is very common that as your application gets bigger and more popular, some things start to go wrong, and I wanted to address some of those. So we kind of did introductions at the beginning. So a lot of you already know that I had a bit of a web developer background, and I've been working with Shiny itself for the last 3 years. And as it's been tradition in these last couple of presentations, I will also like to start with a familiar story. So this will probably be very familiar to a lot of you. So you or your team get a task to do a Shiny application. Maybe it's a POC, maybe it's just a simple Shiny application that your company needs. And you roll up your sleeves and you get it done and you make a successful application. And you start getting your first user. So the first user comes in, everything is great. A few more people hear about the application. They also start using it. You start getting a lot of feedback, a lot of traction, and everyone wants to use it. And more people start joining, and eventually everything starts going bad. So uh, either your machine stops working because it's running out of processing power, maybe there's not enough memory, maybe users are blocking each other, maybe even the network isn't enough. And of course, you, as the original builder of the application, start getting questions. Why? How can you fix this? You start getting a lot of, you start having to go online and starting to check how can you make your application faster? How can you scale Shiny? How can you build a scalable application? I'm sure a lot of you already went on Google and wrote a lot of these. So I would like to try to answer a bit the how, the what, and the why. Um, so when it comes to scaling itself, how you can scale Shiny, there's two ways, let's say two axes where you can actually scale Shiny. So the first one is this horizontal scaling. So if there's not enough machines, you can just add more machines. You can add more servers to serve your application. And then you have this vertical scaling. So by vertical scaling, I mean, how can you make one server actually allow more users to use the application? So of course, the easy solution is just make your machine bigger. But there's actually a second option here, which is you can also make your Shiny application a tiny bit smaller. Um, so basically, in both of these axes, there are three things that you're kind of scaling. So the first one is the size of the machines. So you can just ask your IT department, could you make the machine bigger? Could you add some memory, add some CPU? And this might be enough for your specific case. Maybe you don't have 500 users. Maybe you just need to go from 5 to 10, and this is fine. You can also add more servers. This is more of a mid-level case where you want to go from 50 to 100 users, for example. You can add another machine, and here you do get into the issue that you do need to have some way to balance to distribute the users between those machines. Connect is actually super easy to do in this case, so I definitely recommend it as a deployment option. If not, there's also a lot of load balancing and orchestrating technologies, even completely outside of Shiny that you can use, or maybe your IT department knows about. And then the third option that I mentioned is make your Shiny application smaller. And I think the previous talks already touched this a bit. So there are a few ways that you can work in this specific case. So the first one is leveraging your front end. So use more JavaScript, move more of the computation to the browser, because when you're creating a Shiny app, the browser is free. It's free computing power that you're not using. So if there is something that you can run in the browser instead of having to go back to the server, you're going to save a tiny bit of memory, you're going to save a tiny bit of CPU, and maybe you can squeeze a couple more users in. The second one is to extract computations. So if you're running a very heavy model, you might want to consider running this not in your Shiny application itself. So maybe use something like Plumber or other API technologies. Maybe this is something that you're simply doing on a database, and you can do it on the database itself. So trying to make these very long, very hard computations outside of Shiny itself. And finally, using a database. So like I mentioned, not having the data outside of the Shiny application itself actually means that you will need to use less memory, you will need to use less CPU, and this really adds up when you're trying to scale very, very, very high. So in short, two of them are very easy to use. You can just throw money at them and kind of find and kind of help with the scaling. The third one does require a bit more finesse, a bit more hands down in the coding. Before I touch too much into this part about making the application smaller, I think it's also important to say why this works. So why does making your application smaller actually works? The first one is because of the Shiny concept of reactivity. So many of you might know that Shiny is single-threaded. This means that it can only do one thing at a time, and this is just a byproduct of having R, of having it built in R. And this is also why very often people say that Shiny isn't production ready. You cannot scale Shiny. Well, you can if you're careful with your resources. And reactivity is one of the let's say things that when you understand, you can kind of leverage it to your advantage. So how does reactivity actually work? So if you see here, reactivity is basically any type of reactive list, reactive value that you have. In this case, for example, input values are also reactive. All of these are taken, the entire graph of how things are processed is kind of taken care for you when you use reactive values. So in this case, for example, whenever this input value changes, it will leverage reactivity to output, to update this value without you actually having to do anything. And reactivity is actually can trigger a lot of things. So because you're not really in control of reactivity most of the time, it actually means that HTML, CSS, JavaScript, other assets can be being sent to the browser, and this will block your application even more. So always be mindful of what your reactivity is doing, and this will also let you clean a bit more the resources that your application is using. So in this case, a simple example of reactivity is that when you build this slider input, the first step is that all of this HTML to create the slider, all of the styles, all of the assets are sent to the browser. There is then an extra step where JavaScript is added to those static assets to actually create a bi-directional communication channel, which is a WebSocket. And finally, the value is actually sent, the initial value, and the server returns with the value to the browser. So basically, by leveraging this reactivity, all of this is actually happening behind the scenes whenever you update a reactive value. So there's a lot going on. It's not like it's a simple thing that you just updated the value and it seems like not much happened, but there's actually a lot happening in the background. Why is this important? So in this case, we're simply printing a value. So there's actually not a lot happening. But since R is single-threaded, this means that instead of this print, if we're actually doing a very long and complex CPU operation, Shiny will be blocked for the time that it takes to actually run this function. So you really want to avoid this. And this is where having either more JavaScript running these very long operations, maybe leveraging REST APIs, for example, or even, for example, having it as a promise that the request to run this computation is sent to another service. And then whenever the service actually finished, then the value gets updated. This will make your application less, appear more responsible to the users themselves. So like I mentioned, blocking computations, single threading, this is something that you really need to keep in mind. And I'm slowly running out of time. Okay, so how do you actually leverage the browser to prevent a lot of long-term operations of blocking your application? So the first thing is, I see this very often where render functions are being used slightly incorrectly. So if you're familiar with any kind of input from Base Shiny or from any of the UI packages that are available, you might know that each input element actually has a corresponding update function. And these update functions are actually very important. So in this case, for example, if we have a render UI and we're then rendering the input itself, what we're doing is we're doing all of that sending of the HTML, the CSS, the JavaScript, creating the bindings. We're doing all of this again. So even a simple example as just rendering a numeric input, rendering a simple input by having it reactive and having it be redone every time something changes, you're going to spend maybe half a second, maybe a few more CPU cycles, and this is enough that maybe you won't be able to squeeze one more user in. So make sure that you leverage these update functions. These run completely under JavaScript, so there's actually no overhead in running them. This is just a message that goes through the WebSocket, and the Shiny framework itself has a JavaScript component that knows what to do when it receives a specific update function. So here we can already save a tiny bit just by, this is using the power of the browser without leaving Shiny itself. But we can also leave Shiny itself. So this is where you can, for example, leverage Shiny.js. So Shiny.js lets you run JavaScript or lets you trigger JavaScript from Shiny. So this is a good middle step between staying in Shiny and going fully into JavaScript. You do need to have some knowledge of JavaScript for this, but it really helps with making your application a tiny bit lighter. So if you're, for example, just rendering an alert because you need to call the attention to the user, use JavaScript for this. It might not look like much, but remember all of those assets that Shiny needs to send. An alert is a simple JavaScript function. It already exists in the browser. It has very little overhead. And finally, if you want to go even a tiny bit further, you can set the JavaScript without even going through the server. So for some of these elements, this means using inline JavaScript events. So for example, onClick is actually an attribute of the HTML that generates this action button that will trigger this alert without even going to the server. So Shiny doesn't even know that this onClick event happened, and especially for any kind of feedback or UI changes that Shiny doesn't really need to know because it doesn't affect how the logic, what the logic actually is or how the state of the application actually is. This is a much better option. And of course, here I'm using the example of an alert, but if you are familiar with JavaScript, you can do even your own custom JavaScript and trigger it without going through the server with something like Shiny.js. The second thing that is also very important to understand is the database. So why do we keep pushing this idea of the database? Why should you use a database? And this is just a simple piece of pseudocode that just reads a bit of data into memory, and now there's some filtering going on in that table, and then we're rendering the result. And this is a very common usage. You see this very often in Shiny applications, and this does not use any type of database. This simply loads that data into memory, and now it exists in memory, and the Shiny app can do any kind of manipulation. Right? Why is this bad? So let's take an example of small. Let's go back to our small application. So we have 5 users. We have our machine, and we have a few different R processes that are running some information, some that are running the Shiny applications for those users. Each of those processes, if we assume that the data is around 1 gigabyte, each of those processes is using 1 gigabyte of memory. For 5 users, we'll be using 3 gigabytes of memory. For 13 users, we're already at 7 gigabytes of memory. For 26 users, we already be on gigabytes of memory data set and on our application. So you can kind of see this scales very badly. And this is where using a database can help you. So if you use something like dbplyr, for example, Jordan, I did went down for a second. I did got the notification. So if you use a database instead of actually loading information into the R process, you basically can run a much larger number of users with a much smaller amount of memory. So in this case, every process would use just whatever it needs to run your skeleton Shiny framework. And this could be 100, 200 megabytes instead of 1 or 1.5 gigabytes per user. So just to quickly sum up, in addition to those paid easy solutions where you can just scale the actual size of the service, remember that you can leverage the front end so use JavaScript to handle the user interactions that don't really need to change anything in the data. Make sure that you extract computations. So take a look at things like Flask or Plumber or any kind of API that could help you with not having to run so much heavy computation on the process where you're running a Shiny application. And finally, make sure that you prepare your application to be used by many users. And a good rule of thumb is always make your Shiny layer as thin as possible. And just another small idea of how this would work. So to leverage front end, just make sure that things stay in the UI, don't go to the server. Make sure that you use external services and databases as much as possible. And finally, scale your architecture. And here, testing can become very important. So things like Shiny load test can actually let you understand how much computation power one instance of your Shiny application needs, how much 50 would need, how much 100 you need. And you can even run these at, you can use things like Shiny load test, for example, test, can this run for 100 users? And if it can, then you're good. If not, you can tweak the sizes of the machines, the number of the machines, and try again. And finally, I think Damian from Appsilon made this analogy, which was very good. You want your Shiny application to not be like your typical chess player that needs to spend a lot of time in each interaction. You want them to be the ping pong player that returns the question as quickly as possible and tries to be always free just in case a new request comes in. Okay, and that's it from my side.